Good morning, students. Today your learning target is going to be that you can multiply pairs of linear factors to produce quadratic expressions, and you can also factor quadratic expressions into their linear factors. And we're going to start off with a warm-up do now. Please answer these three questions. Simplify each one by using distribution. So you can pause the video, and when we get done, I'm going to have you show me your answers. Go ahead. All right. Let's take a look at your answers. Show me your answers to the first problem. The quantity 4x times the quantity x plus 7. What did you all get? All right, that looks good. Everyone who's showing me the correct answer of 4x squared plus 28x, the 4x just gets distributed to both of those terms, and they get added in the middle. The 4x times x is 4x squared, and the other product is 28x. Very good. Okay, now please show me your answers to number 2. All right, most of those look pretty good. I have, let's see, I've got a couple people showing me this answer, negative 6x squared plus 18. So let's take a look. So this 2 has to multiply to how many different terms? Correct, all 3 terms. So the 2 is going to multiply the x squared, it's going to multiply the negative 4x, and it's also going to multiply the 9. So every one of those blue terms is going to get double. And when we do that, we get 2x squared minus 8x plus 18. Now some of you have this answer, minus 6x squared plus 18. So who can tell me what they did? All right, so you added, or you combined these two terms, you subtracted them. So you did positive 2x squared minus 8x. So you said 2 minus 8 is a negative 6, and then you brought along the x squared. Is that correct? Can we do that? No, why not? Because they're not what? They're not like terms. And what makes like terms? We need 2 things to have terms be like terms. Same variable and the same exponent. So when no exponent's written here, what actually is the exponent for the negative 8x? What's the exponent on the x if we don't write it? It's a 1, right? It's implied. This is a 2. This exponent is 2. This exponent is a 1. We cannot combine these because they're not like terms. So you cannot combine the positive 2 and the negative 8 to make it negative 6. Okay, you have to leave it like this. All 3 of these terms are not like terms, so we cannot simplify it by combining them by adding or subtracting. Okay? Please show me your answer for number 3. 6x minus 1 times the quantity 2x plus 3. All right. I see your whiteboards. And some of you have this answer, 12x squared minus 3. Let's take a look. Now, here we have 2 terms times another expression with 2 terms. What's a 2-term expression called? It's a binomial. So we have a binomial times another binomial. Now, here, the first problem is we only had to distribute the 1 term on the outside to 2 terms here and distribute this 1 term to 3 terms here. But now we have 2 terms times 2 more terms. So we actually have to multiply 4 times. And to do that, we use the F.O.I.L method, which helps us keep it organized and make sure we don't miss any of the products that we need. So F.O.I.L stands for first, outside, inside, last. And here's what it looks like. The first term in this binomial is 6x. The first term here is 2x. So it's going to be 6x times 2x, which is going to be 6 times 2 is 12. X times x we know is x squared. That's the first of the 4 multiplications. The O is for the outside, the ones that are farthest apart. So this term is 6x times 3. That becomes 18x. The I is for the inside terms. Negative 1 times 2x is going to give us negative 2x. And the L is for the last term in each of the binomials. Negative 1 times positive 3 is negative 3. So we have 4 sets of multiplication, 4 pairs of multiplication, and we get 4 products. Then, what does my CLT stand for? Combine like terms. So we can't combine the x squareds with the x's, but we have 2 terms with x's that have an exponent of 1, which is implied, is not written. So we can't do 18 minus 2 is going to give us 16x. So it's 12x squared plus 16x minus 3. So who can tell me what, the few of you who had this answer, 12x squared minus 3, what did you do? What did you miss? Okay, you did the first terms, you multiplied 6x times 2x and got the 12x squared, and you multiplied the last terms, the negative 1 and the 3, but you didn't do the outside or inside. So you have to pay attention when you have two binomials because we're going to be doing this a lot. You have to multiply 4 times. FOIL gives you the way to set it up so that you don't drop any of your pairs of factors that you're multiplying and that you do all 4. Then you will be combining your like terms for the middle 2 terms, and you'll have a third term here. Okay, not 2 terms. Sometimes you will end up with 2 terms, but even if you FOIL correctly, but we haven't gotten to those yet. You will be getting to those. All right, let's give everybody a chance to recoup. And I'm going to ask you to FOIL this problem right now. You're going to simplify. These 2 binomials are multiplying each other. Go ahead and FOIL that. You can pause the video. And when you're done, show me your answer. Okay, everybody's getting this answer correct. So this one's a little bit easier. So we had x times x was x squared. Our outside product was negative 3 times x was negative 3x. The inside product was just 1x. And the last term in each binomial gave us a positive 1 times negative 3 gave us a product of negative 3. You combine the like terms correctly. Negative 3 plus a positive 1x gave us negative 2x, and that was the correct answer. So everybody got that correct. Good job. Now, so now for the first time we have a quadratic we're talking about today. What makes this quadratic is this exponent of 2. Up till now, we've really only been using linear expressions and linear equations where the x has the implied variable of 1. That's called linear. So this is a linear binomial. This is another linear binomial. We multiply these 2 linear binomials, and the x times the x gave us x squared. The squared, the 2 exponent for the x, makes this what's called a quadratic. So for this unit we're going to be working on is going to be all about quadratic expressions and equations and functions. So today we're going to talk a little bit about the quadratic. We multiplied these 2 linear binomials and got this. Here I have a very simple problem. 2 times 3 equals 6. Well, if I multiply 2 numbers, or 2 expressions, what's the answer to a multiplication problem called? Yes, it's a product. What are the 2 and the 3? If this is the product, the 2 and the 3 are the whats of 6. Good, they're the factors. So we take factors and we multiply them and we get a product. What if I turned it around and said the product is 6? Tell me what the factors are. Okay, well you know that 2 times 3 are factors of 6. Are there any other factors of 6 besides 2 and 3? Okay, good. 6 equals 1 times 6. So this is another pair of factors of 6. Do we have any factor pairs that aren't just positive numbers? Can we have negative factors or factor pairs of 6? Okay, good. We can just make these 2 numbers negative. We can do 6 equals negative 2 times negative 3. And that means we can also do what? Yes, 6 equals negative 1 times negative 6. So altogether, including positives and negatives, we have 4 different pairs of factors that have a product of 6. So I know you know how to multiply, and I know you know the product is the answer to a multiplication problem. Well, we're going to work more on foiling to get a product, but now, in a minute, we're going to be turning this around where I'm going to give you the product, and I'm going to ask you to give me the factors. So we're actually going to do like the reverse of foiling. It's going to be the inverse of it. We're going to talk about that in a second. But I'm going to talk a little bit about quadratics for a second here. So we have this quadratic equation, this quadratic expression, x squared minus 2x minus 3, and it's in what we call the standard form of a quadratic. Now, back when we did linear equations, we had a standard form of a linear equation where we could graph the intercepts based on the standard form. But now this is a standard form of a quadratic, and it's going to look like this. ax squared plus bx plus c. This is what's called the standard form of a quadratic expression or a quadratic equation. And this is in this form. There's 3 terms. We have an x squared term, we have an x with an exponent of 1, and we have a term with no variable. The first term that has the x squared is going to be called the quadratic term. That's what makes it quadratic, is the exponents of 2. The plus bx is the linear term because the exponent is 1. Just like when we had a linear binomial here and here, the exponent was 1. The c doesn't have a variable. It remains constant. So like this number here, here's the constant term, negative 3. That's never going to change because it doesn't have a variable. So this is the constant term, it remains constant. A and B are the coefficients of the variable term. So these are both variable terms. This is a constant term. It's not going to change. The variable term, we have a variable which we don't necessarily know what it is, but the a is the coefficient of the x squared term. The b is the coefficient of this x to the first power term. They're the coefficients. The c is the constant term. So I want you to get used to setting these up where the exponent of 2 term goes first, then the exponent of 1 for the x goes second, and the term with no variable goes third. It's going to be ax squared plus bx plus c. That's how we're going to get used to talking about and working with quadratic equations and quadratic expressions. So here's the same quadratic trinomial that we just got when we FOILed that simple problem. Now I want to ask you this. What's a in this expression? What is the coefficient of quadratic x squared term? What number is in front of x? If there's no number, the number is what? It's a 1. It's implied. The same way we don't have an exponent in a linear term because the exponent is 1, it's implied. We don't have to write it. It's not wrong to write a coefficient of 1, but we normally don't write it. We normally never write an exponent of 1. What's the b term? What is the coefficient of this linear term? It's just the number that's in front of the x, and it's obviously it's -2, and the constant term is going to be correct, -3. So any questions on that? You need to be able to identify the coefficients of the 3 terms in a quadratic expression or a quadratic equation written in standard form. What's the number in front? That's a of the x squared term. The coefficient of the b term of the linear term is the b is negative. So the x squared doesn't go here. The a is just the number in front. The b is -2. It's just the number in front of the x, and the c is the -3. Now, I just talked about factoring. We talked about what are the factors of 6. Now I want to know what are the factors of this quadratic trinomial. A is 1. We're going to start with A being 1. And that makes it much easier because what did we multiply to get the x squared? What times what equals x squared? Right, it's just x times x. So it's always going to be that. So this is our product. We want to get the factors. Now, this is what we FOILed to get the actual product after we've multiplied 4 times. So it's always going to be when a equals 1, it's just x squared in the front. We know we're going to have x times x in the binomial, in the front of each binomial. And that came from the first times the first part of FOILing. The c term came from the last. It came from the last term in this binomial times the last term in this binomial, 1 times -3. So that's pretty straightforward. The question is, what produced the b term of the -2x? And that came from, the b term came from doing the outside, the x times the -3 was -3x, and the inside, the 1 times x was 1x, and then we combined them, the -3x plus the 1x gave us the -2x. So the b is -2, but let's say you didn't have the 2 linear factors in front of you. You're trying to determine what are the linear factors. That's what you were trying to do, the reverse of FOILing. Well, the -2 comes from the factors of this -3, and they're added together. 1 minus 3, or 1 plus a -3. That's the sum. And the c is just the 2 numbers multiplied together. So this is the pattern that we're going to look for whenever we're solving a factoring problem of a quadratic when a equals 1 is just x squared. We know it's going to be x plus or minus a number and x plus or minus a number. Well, the trick is to find these 2 numbers. That's what we really have to do. The b is going to be the sum of whatever these 2 numbers are, and the c is going to be the product. The c here is going to be the product of whatever these 2 numbers are. So we're always going to be looking for the 2 numbers that multiply to the c term that add up to the b term. So here this problem is really about what are the factors of -3 that add up to -2. And for this problem, it was 1 and -3, and that goes in the back of the binomial. So let's do one together here. Let's factor x squared minus x minus 12. First step, let's identify a, b, and c. All right, everybody, what's A? A is going to be 1. B is going to be, right, it's -1, and C is -12. Well, now we're going to use the same process we just talked about. It's going to be x plus or minus a number times x plus or minus a number. These will be our linear binomials that multiply to the quadratic trinomial. X is the first degree. What are the two numbers? So we want factors of C, which is -12, that add up to or have a sum of B of -1. So the factors of -12, and we want the sum of those two factors to have a sum of -1. Well, we can start out with 1 times -12. If we add those together, that would be -11. If we switch the negative to the 1, 1 times -12 is also going to multiply to -12, but it only adds up to +11. We need it to add up to -1. So then we try 2 and -6. They're factors of -12, but they only add up to -4. -2 times 6 are also factors of -12, but they add up to +4. And then when we get to 3 and -4, they multiply to -12 and they add up to -1. So that's going to be the correct factor pair. If we'd switched it to -3 and +4, we would have had a sum of +1. So we just take our two correct factors, 3 and -4, and we put them, +3 and -4, we put them into the back of the binomials. X plus 3 and x minus 4 is going to give us the correct pair of linear factors that multiply to our original quadratic trinomial. You could check this by FOILing. X times x is x squared. The outside product is x times -4, that's -4x. The inside product is +3 times x is +3x. So -4x plus +3x is going to give us a -1x, and +3 times -4 is -12. All right. Any questions on that? Now, you're going to try one on your own. You're going to try to factor x squared plus 13x plus 40. Now, first you should identify A, B, and C, and the goal is to find out what two numbers go in the back of these two binomials. So it's the same process as this. You can pause the video right now, and when you're done, hold up your answer for me. Go ahead. Okay, everyone's on the right track. These numbers are all positive, so we're really not going to consider any negative options. We wanted factors of 40, the C term, that had a sum of the B term 13, and the correct pair of factors are 5 and 8 because they add up to 13. So the correct linear binomial factors of the quadratic are x plus 5 and x plus 8. And it doesn't matter which order you write these. You could have written x plus 8 and x times 5, because if we go back to when I just talked about factors in a product, 2 times 3 is 6. If I switched it to 3 times 2, is that still going to equal 6? And it does. So the order you write the factors doesn't matter. You just have to make sure you put them both in parentheses to show that the parentheses multiply each other. And that is the answer. The other factor pairs do not have the correct sum. Even though these all multiply to 40, they don't all add up to 13. So that's the process. When you have A equals 1, and it's just x squared, we have 1x squared. It's about numbers that multiply to the C term, that are factors of C, and those same two numbers have to have a sum of B. All right, I'm going to give you some more problems to do, and we're going to pause the video and let you go to it. Good job.